Hello and welcome to today's video, which is about recursion in C++. Recursion is when you create a recursive function. Now, a recursive function is a function that calls itself. Let's say you created a function like this one, which simply prints the output 1, 2, 3, 4, 5, because it simply counts the number from 1 to 5, okay? So this is a iterative function. It uses normal loops like a for loop or even a while loop, so it is called an iterative function. Now, a recursive function doesn't use any loops, rather it uses itself, meaning that inside the implementation of the function, you will call the function again. Let's see how by providing the basic structure of a recursive function. Now, this is the basic structure of a recursive function. As you can see, first we have a condition. This is called the base case. It is the condition that will stop the recursive call. So we know that in normal loops, we have something called an infinite loop. Here, if you want, it is the same thing. We have a infinite recursion if you want. So the base case is used to stop the recursion, okay? Just like the break keyword in normal loops. So, after the base case, we have something called the recursive call. This is where we will rewrite our function name and perform a recursive call, which we are rewriting the name of the function, meaning we are recalling the function inside its own implementation. This is called a recursive function, okay? Now, how do we build a recursive function? Let's go ahead and build a function that simply counts from 1 to 5, okay? So let me go ahead and delete all of this, and I'll call my function void like this, count recursive, okay? It is a recursive function. Now, what I'm going to do with this function is that I'm going to provide it a parameter called start, and it should be an integer. Now, let me go down to the main and say count recursive and provide it with 1. So because I want to start counting from 1, I will give it as first parameter 1, okay? Now, because I want to stop at 5, what I will do is I'll use a base case like this. I'll say if start equal to 5, what I'm going to do is simply print start, okay, print the element, and after it, I'm going to use the return keyword to completely cancel or exit the recursion. So, when you use the return keyword inside a recursive function, what it will do is that it will simply exit out or stop the recursion of this function. So basically, in a normal loop, we use the break keyword to stop a loop. Here, if you want, think of the return keyword as the break keyword that will stop the recursion. Okay, so the return keyword, again, when used in the context of recursion, it will stop the recursive call. Okay, and even if it is a void function, we are using a return keyword that simply doesn't return anything, so it's okay. Okay, now let's go ahead and say else, and now we will provide the recursive call. First of all, I'm going to say cout start like this, simply printing the elements, and after this I'm going to call the function again by simply typing its name, but this time I will provide it a different parameter. I'll say something like start plus 1. Now, in order to understand recursion, we need to understand a concept called the call stack. Now, the call stack is a data structure that stores active functions, and the first element inside that call stack is the main function because it is the first function executed in our program. Now, inside the main function, we called actually our recursive function, so it will be stored inside the call stack and above the main. Now, the compiler will execute the recursive function. It will start by checking the first condition or the base case. So at first, 1 is not equal to 5, so basically the base case won't be executed, and so we will jump to the else statement where we will print the number and again call our function, but this time we are passing 2 to the function because we increased start by 1. So now we have another element inside the stack, and again, if you execute this, you will get again the same function but with different parameter. This will continue all the way to 5. Once we've reached 5, we need to stop everything because the base case is met. And now we start falling back to where we begin, which is when we called the function and gave it 1, right? So watch carefully this animation and how the output of each function is being combined with the function or the previous function called before, and until we arrive to the starting function or the first function we used to call our recursive function. So this is what's happening behind the scenes with a recursive function. Now, if you want to see the output, let's go ahead and compile our file, and then let's launch it. As you can see, it prints 1, 2, 3, 4, 5. Now, the second recursive function we will see today is how to find the factorial of a number. Say you want to find the factorial of 5, for example. What you'll do is you'll multiply 5 by 4, by 3, by 2, by 1, and stop right here, right? So this is a factorial of a number. Now, let's do this in C++ using a recursive function. Let me go ahead and delete all of this, like this, And this time I will I will define a function with of return type int. And I'll call it factorial like this, and I'll get a number, okay? Now, let's go ahead down in the main and call the factorial or recursive function. But first of all, let's say cout and factorial like this, so we can display the output of the factorial of 5, for example. And let's go ahead now and provide the implementation. So at first, we need to define a base case. So I'm going to say something like this. If my number becomes 0, and we know we cannot multiply a number by 0 in factorial because in the end we will get 0. So what will happen is that once we reach 0, I'm going to return 1. Okay, so when you multiply a number by 1, nothing will happen. Okay, so it won't affect the equation. Now let's go ahead and write the base case, or the recursive call. So else, what I'm going to do, and first of all, because this is a function that has a return type, what I should do here is I should write return like this, and watch what I'm going to do now. I'm going to say number multiplied by factorial of number minus 1. Okay, like this. Now, just to be clear, we need to decrease the number parameter at each recursive call to be able to eventually reach the base case. So that's why I'm saying number minus 1, right? Also, we said return here because we have to return something, and the type of the function is not void. That's why. Now, let's see this animation. So basically, you start by calling the function and passing it 5, right? What this will do is that it will say something like 5 multiplied by factorial 4. Now you need to call factorial 4. What this will say is 4 multiplied by factorial 3. So you have to repeat this process until you reach factorial of 0. Now, when you have factorial of 0, what it will do is it will return 1, because number now is equal to 0, so we will return 1. And now the base case was evaluated. What will happen now is that we will fall back, and now the correct term of it is called stack unwinding. But let's not get too overwhelmed by the terminology. Anyway, so when it falls back, the output of each function call will be combined with the previous functions. And as you can see here, outputs are being added up together in the end. We will reach 120, which is the correct output for factorial of 5. So if you want to test it out, let's go ahead, compile, and launch. And as you can see, we got 120. And now let's go ahead and create our last recursive function for today, and which will be a power function. So basically, let me go ahead and delete this, and I'm going to say something like int power, int base, and int exponent. So what it will do is that you'll provide it a base, like 2, for example, base 2, and an exponent, for example, 2 to the power 3. It will be 8, right? So let's go ahead and try it. Try to build a function like this one. So I'll say power 2, let's say 5. Okay, why not? 5. So we should get 32, okay? Now, before we start by developing the implementation, we know that we need to start by the base case. So I'm going to say if xp or exponent reaches 0. What will happen here is I'm going to return 1. Well, basically a number to the power 0 will return 1, okay? Now look what I'm going to do here. I'll say else, and this is the recursive call. I'm going to say return like this, and base multiplied by power. So I'm going to call the function again, and basically I will pass it base, but what I'm going to do here is I'm going to say xp minus 1. Okay, so I'm decreasing xp at each recursive call. So like this, eventually we will reach the base case and return 1. But again, what's happening here? Let's go ahead and see it. So now what will happen is that you will start by calling the function. For example, pass it, I don't know, 2 to the power 3, for example. Now at the first execution, definitely exponent won't be 0. So at each recursive call, you'll notice that xp or exponent will be decremented until it reaches the value of 0. What will happen here is that we will return 1. So each output will be multiplied by the previous output, and as you can see, we are basically multiplying base with itself multiple times, because this is how power functions actually work, right? So as you can see, in the end, we'll reach a certain output, which is the 2 to the power 3, which is going to be 8, right? In our case, we said power 2 to the power 5, so we should definitely get 32. So let's go ahead and see it. We got 32. Let's go ahead and say something like 2 to the power 3. We should get 8. So we got 8. This function actually works. And so this is the recursion for today's video. Now, one thing you need to know about recursion is that it takes too much space. So you're basically adding this function into the call stack, which will eventually take too much place inside the call stack. And if you like recursively call a function to a point where the call stack is full, that can cause an error called stack overflow. But either way, I hope you found this video helpful. Thank you for watching today's lesson, and make sure you subscribe to stay up to date with me in this C++ tutorial. Now I invite you to click on one of these end screens that will appear right now, and I hope to see you in the next video.